Welcome back everyone, Patrick here, moving on to the next question. So a follow-up from the previous video where we have to find the missing variable in each scenario. So in the previous video we were dealing with a square and a rectangle. Notice here we're going to be dealing with a cube, so we're going to be dealing with a three-dimensional shape. So in scenario A we're told a cube has a volume of 27 centimeters cubed. We have to find the surface area. In the next scenario, we're told that the side of a cube has an area of 16 centimeters squared. We have to then find the volume. And then in part C, the surface area of a cube is 24 centimeters squared. And then we have to find the volume, right? So just different kinds of scenarios. Now, before we get into these, just want to quickly go over the different properties of a cube. So if we draw one over here like that. So with a cube, notice that because it's three-dimensional, we're dealing with a length, a width, and a height as well. And a cube, all of those are the same. So what we can do is we can actually label those x, x, and x, right? The length, the width, the height, they are all equal for a cube. If you were dealing with a rectangular prism, right, those would all be different, but because we're dealing with a cube, all of them are the same. So a couple of things. What is the volume? Well, the volume would be the length times the width times the height. So in this case, it would just be, for a cube, x times x times x, right? And we could combine these and make it x to the power of 3. So in general, the volume of a cube is equal to whatever the length of one of those sides is to the power of 3. Right? So for example, let's say that one of the lengths, right, or all of the lengths are 5 centimeters. We'd have 5 centimeters to the power of 3, which would be like 5 centimeters times 5 centimeters times 5 centimeters, which would give us 125 centimeters cubed. That would be the volume of a cube where the length is 5 centimeters. Okay, so that's the volume. Now notice that we're also given information about the surface area in these scenarios. So the surface area of a cube, what is it going to be? Well, it's basically going to be the area of all of the sides added together. Now for a cube, how many sides are there? Notice there's this one in the back, one up top, 2 on the side, so that's 4 so far, 1 at the bottom, and then 1 in front. There's basically a cube has 6 sides. Now what's nice is that each side has the same area, right? Because the length, the width, and then the length, the width, the height, they're all the same. So what's the area of one side going to be? So for example, if we look at this side in front here, what's the area of this going to be? Well, it's just going to be x times x, right? So the area of one side, let's actually write that, let's write it over here. Area of one side is equal to x times x, which is just x squared, right? Notice that area, it's two-dimensional, right? So forget about the rest of the cube, and we're just looking at this square over here. Each side of a cube is a square, right? So the area of one side, or the area of a square, is just x squared. Well, because there's 6 sides, we're going to take that area of one side, multiply it by 6, so it'd be 6x squared. That's what the surface area formula for a cube is going to be. And notice it's going to be two-dimensional. So going back to that previous example, if we have a length of 5 centimeters, well, 5 centimeters to the power 2, which would give us 25 centimeters squared, and then 6 times 25 centimeters squared would give us 150 centimeters squared. So going back to that example that we had before, a cube that has a length of 5 centimeters has a surface area of 150 centimeters squared. And notice that it's two-dimensional, right? Because we're dealing with area versus volume. Before, it was 125 centimeters cubed, right? It was 3. dimensional. So the surface area is always going to be, area in general is always going to be two-dimensional. Okay, so just wanted to go over those general properties before we jump into these problems or these scenarios here. So let's start off with scenario A. We're told a cube has a volume of 27 centimeters cubed. We have to find the surface area. So notice first we have to find that x variable because we're given the volume. So what we can do, set up an equation, 27 equals x to the power of 3. And then once we get that x, we could plug it into the surface area formula to get the surface area. That's what they're asking for, right? If they were just asking for the length of the cube, then just getting the x would be enough, but we got to do 2 steps. We got to get the x, then plug it into the surface area. So what number multiplied 3 times by itself would give us 27? If you think about it, it's going to be 3. Right? 3 times 3, which is 9, times 3 again, would give us 27. You got to be careful. You don't want to divide by 3 over here because then we'd get an x value of 9 and that would not be correct. Right? 9 times 9 times 9 does not give us 27. Okay, so the answer is 3. And if you want to get this a little quicker with your calculator, so it's going to be a little bit more advanced, but what you can do is whenever you have, let's say we're solving for, let's say we're trying to get this x by itself, what we can do to get it by itself is we could take the other side to the power of 1 over n. All right? That's how we can get this by itself. So if we apply this rule over here, we can say that x, so notice that the y in this case is the 27, the x is the x, and then the n is the 3. Well, if we want to get the x by itself, we would take the y, which is the 27, take it to the power of 1 over n, 1 over 3. And then if you plug that into your calculator, just making sure that you put everything in brackets, you'd end up with 3 for x. Right? It's a little bit more advanced. But yeah, if you want to get it quickly versus thinking about what number multiplied by itself 3 times would give you that volume. Okay, whichever way you do it though, we get 3. So each of these lengths in this case, right, is 3 centimeters. This is 3 centimeters, this is 3 centimeters, this is 3 centimeters. A cube that has those lengths has a volume of 27 centimeters cubed. But now we have to find the surface area. So once we have that x, we can now plug it in here. So we'd have the surface area equaling 6 times 3 centimeters to the power of 2. So we'd have 6 times 9 centimeters squared, right? So that 9 centimeters squared represents the area of one side. 3 centimeters times 3 centimeters, 9 centimeters squared. But then there's 6 sides, so we got to multiply it by 6, so we get a total surface area of 54 centimeters squared. So that would be the answer to scenario A. Now moving on to scenario B, so we're told the side of a cube has an area of 16 centimeters squared. So let's erase all of this over here. So remember, we mentioned how the area of one side over here, let's actually erase this 3, so we got x, x, x. So remember, we said that the area of one side is basically x times x, right? It's the area of this square over here, which is x squared. So that's what we're given in this scenario. We're given the side of a cube has an area of 16. So we're told this side has an area of 16 centimeters squared. And given that, we have to find the volume. So again, what we're going to have to do is use this over here. So we know 16 centimeters squared is equal to x squared. Right? We could solve for this x here, which is going to be the same for all of these. And so what number multiplied by itself, right? What number multiplied twice would give us 16? Well, it would be 4, right? So x would end up equaling 4 centimeters in this case. If you wanted to use that other formula where we isolate for the x would equal 16 to the power of 1 over that n value, which is 1 over 2. If you plug this into your calculator, you'd end up with 4. This is like the same thing as the square root of 16, but it's not always going to be a square root. As we saw in the previous example, we had to take the third root, right? So it was to the power of 1 over 3. That's why I like this formula. It's a little more general where you could apply it to more things. But 16 to the power of a half is the same thing as square root of 16, which would give us 4. So in this case, we're dealing with a cube that has a width of 4 centimeters, a length of 4 centimeters, and then a height of 4 centimeters, right? So the area of one side is 16, 4 times 4. But now we have to find the volume. So now that we have that x value, we plug it in here into the volume. So we'd have the volume equaling 4 centimeters to the power of 3. We could rewrite that as 4 centimeters times 4 centimeters times 4 centimeters. And then if you do that in your calculator, you'd end up with 64. And that would be centimeters cubed, right? Cubed because we're dealing with volume, which is 3-dimensional. So in this particular case, in part B, we got 64 centimeters cubed, like that. Okay, and then part C finally. Let's erase all of this here. What are we given? We're told that the surface area of a cube is 24 centimeters squared, and we have to find the volume. Okay, so we're bring back our variables x, our unknowns. So in this particular cube, we're told the surface area, meaning the sum of the area of all 6 sides, is 24 centimeters squared. So we would be using this formula over here. So we have the surface area equals 6x squared. So we'd have 24 centimeters squared equals 6 times x squared. So we first, given this information about the surface area, have to find that x. Then once we have the x, like we did in scenario B, we just plug it into the volume. Question is, how do we solve for that x? So in part B, we were given the area of one side. Well, in part C, we're given the area of all 6 sides. So what we can do is we can actually divide both sides by 6. And that would give us the area of one side, right? Because the area of each of these sides is the same. So if all 6 of them have a total area of 24, that means one side, this side over here, or this side, doesn't matter, they're all the same, but in this diagram, this side has an area of 4 centimeters squared. Right? And then it just becomes the exact same question as part B, but instead of the side having an area of 16, it has an area of 4. Right? So we can have x squared equals 4 centimeters squared. And so we could tell that x is equal to 2 centimeters in this case, right? 2 centimeters times 2 centimeters gives us 4 centimeters squared. So we're dealing with a cube that has a width of 2 centimeters, length of 2 centimeters, a height of 2 centimeters, right? 2 times 2, 4 centimeters squared for the area of one side, multiplied by 6 would give us a total surface area of 24. So now we have that x value, and now we could just plug it into the volume. So we'd have the volume equals 2 centimeters to the power of 3, which would be like 2 centimeters times 2 centimeters times 2 centimeters, right? Which would give us 8 centimeters cubed. So that would be the volume of this particular cube in scenario C that we are dealing with. Okay, so just be on the lookout, read these really carefully, be careful with what you're given, right? Notice here we're given the side area. Here we were given the surface area. Understand the difference between them. Sometimes you'll be given a volume and then you've got to find a certain area, right? Maybe in this part A, they could have also asked, what is the area of one side of the cube, right? And that would be, what did we get? We had 3 and 3, so it would be 9, right? If that's what it asked in part A, but they asked for the entire surface area. So it was 9 times 6, which gave us that 54. So just read these questions really carefully and draw diagrams if it helps, and just be super conscious with your steps.